Hello everyone. Today let's talk about sensors, monitoring and controlling. Sensors, monitoring and controlling are very important topics in computer science and information technology. Sensors are devices which read or measure physical properties. So physical properties that sensors detect are temperature, pressure, acidity, gases including oxygen, carbon dioxide, nitrogen, and it can be many more. Sensors gather real data from natural environment. Real data is analog in nature. Therefore, sensor gathered analog data need to be converted into digital before processed by the computer. To do that task, we are using analog to digital converter or computer. There are different terms we are using. The main using term is analog to digital converter. Analog to digital converter is a system that converts an analog signal such as sound picked by a microphone or light entering a digital camera into a digital signal. An analog to digital converter may also provide an isolated measurement such as an electronic device that converts an input analog voltage or current to a digital number representing the magnitude of the voltage or current. You can see in this diagram, we are using analog signal that will input to the analog to digital converter. It will provide a digital signal as the output. Digital to analog converter. A digital to analog converter is a system that converts a digital signal to an analog signal. An analog to digital converter performs the reverse function. Examples are temperature sensors. There are different sizes, different types of temperature sensors available like this. Look at the microprocessor. To the microprocessor, we provide inputs using input devices. It will process the details using ALU, control unit, and register. And to do this task, that will use the memory unit. Finally, microprocessor will output the necessary outputs using output devices. Here are some examples for microprocessors. After that, let's talk about the actuators. What are the actuators? An actuator is a component of machine that is responsible for moving and controlling mechanism or system. For example, by opening a valve, in simple terms, it is a mover. An actuator requires a control signal and a source of energy. The control signal is relatively low energy and may be electric voltage or current, pneumatic and hydraulic pressure, or even human power. Its main energy source may be an electric current, hydraulic fluid pressure, or pneumatic pressure. When it receives a control signal, an actuator responds by converting the signal's energy into mechanical motion. An actuator is the mechanism by which a control system acts upon an environment. The control system can be simple, a fixed mechanical or electronic system, software based, for example, printer driver, robot control system, a human or any other input. This is an example for pneumatic rack and pinion actuators for valve controls of water pipes. This is electrical valve actuator controlling a one-off needle valve. There are several examples of actuators, home drive, digital mirror device, and there's a huge list. And there are many more actuator examples available. These are some of the very important ones. Sensors and their applications. Temperature sensor. It can control a central heating system. It can control or monitor a chemical process. It can control or monitor the temperature in the greenhouse. Moisture humidity sensor that will control the moisture levels in soil in the greenhouse, and it will control the humidity levels in the air in the greenhouse. Monitor dampness levels in an industrial application. For example, monitor moisture in a plant spray booth in a car factory. Light sensor. Switch street lighting on at night and off during the day. Monitor control light levels in a greenhouse. Automatically switch on a car's headlights when it gets dark. Those are the main tasks done by light sensor. Infrared or motion sensors. Turn on the windscreen's wipers on a car automatically detect intruders in a burglar alarm system. Count people entering or leaving a building. Pressure sensor. Detect intruders in a burglar alarm system. Weigh things like check the wear of a vehicle. Monitor or control a process where a gas pressure is important. Acoustic or sound sensor. Pick up noise levels in a burglar alarm system. Detect the noise of liquids and liquids of dripping in a pipe. Gas sensor. Monitor pollution levels in a river or in the air. Measure oxygen and carbon dioxide levels in a greenhouse. Check for carbon dioxide leaks in the power station. pH sensor. Monitor control acidity alkalinity levels in the soil in a greenhouse. Pollution or environmental monitoring in rivers. Magnetic field sensor. Any application where detection of changes in a magnetic field is required, used in anti-lock braking system in motor vehicles. Sensors are used in both monitoring and control applications, but there is a slight difference between them. The difference is how they are using. Let's look at it. This is the monitoring process. Sensors send signal to the microprocessor or computer. The signals are converted to digital using an analog to digital converter. Then the computer or microprocessor analyzes the data received by checking it against the pre-stored data. If new data is outside the acceptable range, a warning message is sent to a screen or an alarm is activated. Then the microprocessor computer has no effect on what is being monitored. It is simply watch the process. In controlling, this is different. In, in controlling, sensors send signal to the microprocessor or computer. The signals are converted to digital using analog to digital converter. Then the computer or microprocessor analyzes the data received by checking it against the pre-stored data. First three steps are same for monitoring as well as for controlling. That is a very important point to remember. Then, in controlling, if the new data is outside the acceptable range, the computer or microprocessor sends signal to control valves, motors, etc. The output from the system affects the next set of inputs. That's the difference between monitoring and controlling. This is an example for controlling greenhouse environment. In this example, you can see there are different sensors are using and the sensors are detecting information. Those information will be managed accordingly. The example continuing. These kind of examples will be discussed in another video. Like, share and comment as well as subscribe to my channel. Thank you for watching and subscribe to my Nirvana Geeks Unleashed to watch more technological videos like this. Have a great day.